When it comes to cybersecurity, it's always been about what threats you're facing and what kinds of threats are imminent. While a threat is something you need to be aware of and protect against, the reality is if you don't know the consequence, or if there's no consequence from a threat, then why bother protecting against it? A consequence based cyber risk management approach is vital for protecting operational technology or industrial control systems across the board from utilities and energy to manufacturing overall. Understanding the impact of an attack and then applying your resources toward that can ensure a stronger and more resilient defense in depth program. Hello, my name is Greg Hale, and welcome to another edition of Today with ISS Source. And with us today is John Cusimano, Vice President of OT Cybersecurity at Armexa. Now, John and I have known each other for a long time, and I must say I've been looking forward to talking to him about this subject for quite a while. So John, welcome to the podcast.
Yeah. Thank you, Greg. Nice to be here.
Well, it's great. It's great to having you here. And like I said, it's been something I've been looking forward to for a while. And I'm going to start off with two questions that are related. And
Mhm.
one is in this industry where there is a different definition for just about anything. I mean, how do you define consequence based risk assessment? And then the second part of the question is, and any manufacturing organization, when working on a cybersecurity program, they have to look at threats and vulnerabilities and consequences. So the question is, why is consequence-based risk assessment so important? So we'll lead off with those two questions.
Sure. I mean, the term consequence-based risk assessment is a little bit redundant because risk is defined by Webster's dictionary and just about any text you go to. The fundamental definition of risk is likelihood and consequence, a function of the likelihood of something bad happening and then how bad could that be, the consequence. So risk, the definition of risk inherently includes consequence. But the reason why we talk about consequence-based risk assessments is really to kind of remind people that consequence is one of the two main variables in risk, likelihood and consequence. And that can be further broken down into sub elements, but basically in order to measure risk, you need to be able to measure or estimate the consequence, or actually more technically correct is the impact of the consequence. Like I said, how
Mhm.
bad could it be? And that definition of risk applies not to just to cybersecurity. It applies to to health risks, to financial risks, any risk you can think of. Ultimately, it comes down to how likely is it that bad thing could happen, and
Yeah.
how bad could it be? Um, so consequence-based risk assessment is really reminding people that when you're measuring risk, you need to know and be able to estimate or quantify what is the actual um, unwanted outcome and how bad could that be. Because too many people tend to misuse that term. They'll be talking about a vulnerability, for example. Oh, this vulnerability in this piece of software is a risk to our business. It may be, but you need to look at it in the context of what if that vulnerability was exploited, what could be the potential consequence and how likely is it that could occur,
Mhm.
to really answer the whole question. We do the same with threats too. We talk about threats, which are a component of likelihood. What is the threat that could occur? And we oftentimes will call a threat risk. Well, a threat by itself is not a risk. It's a potential risk that a bad actor may try to do something, but you don't have risk until that bad actor exploits some vulnerability that results in some consequence.
Mhm.
That is risk.
All right. Now, oftentimes assessments end up conducted by a bunch of folks sitting around in a room, and correct me if I'm wrong, but sitting around in a room in a meeting, asking various questions and getting answers, that kind of thing. But those answers can often be subjective, and by conducting a consequence-based risk assessment, is it possible to get some hard data that shows exactly where you stand?
Yeah. The particularly as I said, there's like the two main variables of risk being likelihood and consequence. It's it's not too difficult to quantify the consequence if you like you said get some people together, you talk about what could be the outcomes of this bad event, and you can start to put some boundaries on those to define. Usually, you tend to focus on worst case
Mhm.
consequence, and kind of maybe work backwards from there. The likelihood side of the equation is much harder to quantify, and that's why a lot of the models for risk management, and risk measurement break down likelihood and consequence into sub-elements. A good example of that is something called the FAIR ontology, that's been published for many years. It's an acronym. It stands for Factorial Analysis of Information Risk. I hope I got that correct, but that's FAIR is a methodology, or they call it an ontology or hierarchy, that breaks down risk starting at the top, first into likelihood and consequence, and then further breaks those elements down. So likelihood, as I said, could be what's the threat? What's the threat actor? How motivated is that threat actor? What kind of resources do they have available? How vulnerable is the system that they might be attacking? What are the access vectors? How hard is it to get to that system? There's a
Mhm.
lot of variables that go into that likelihood side of the equation, and it's not a precise science in cybersecurity. A lot of the same methodologies are used for safety engineering, for example, where we have a lot more data to talk about what's the failure rate of a component. How likely is it that it might fail based on historical data. We don't
Mhm.
have that with cyber. So it's what you're really doing is making a number of subjective estimates, but by combining those and breaking them down into much smaller subjective estimates or ranges, you can do a much better job of getting to um, a reasonable value for likelihood. And again, for most quantitative or semi-quantitative methods, you're not calculating a precise likelihood. You might, like, we see this in like weather forecasting and things like a flood, a once in 100-year flood. It doesn't mean it's going to happen exactly every once every 100 years. It's a way of expressing really what is a range
Yeah.
of the likelihood that a flood could occur every
Mhm.
year. So we're kind of doing the same thing with cyber, when we're estimating likelihoods. We're breaking it down into smaller things that we can reasonably estimate to come up with a an overall reasonable range for what is the likelihood. Is it once every
Mhm.
10 years, once every 100 years, once every 1,000 years? Is one way of expressing it.
Mhm. Now, in this type of assessment, how does technology come into play here? I mean, and then on top of that, where does the human come into play when you're assessing the consequences? So, I mean, you're mentioning that that it's not an exact science, but I got to assume technology really narrows it down. And then, how do the humans come into play here?
Yeah, technology definitely really helps. And in terms of we're getting better and better data as we install systems that, for example, anomaly detection systems or network monitoring systems. We're starting to gather more and more data about the nature of the types of threats and how often they arise. and then we also can use that, use that technology to start to build, I shouldn't say build, maybe to inform risk models. So one of the key things that I think a lot of people um, maybe want to skip over, because I see there is technology out there that will claim to do a kind of a continuous risk assessment on your systems and give you a risk score, a dynamic risk score, which in theory is great. That is, ultimately what probably every plant manager would want to look at in the morning is show me the real-time risk in my facility from cyber. The challenge with that is the way it's been implemented so far. Thus far, the things that I have seen are a little bit too simplistic in how they calculate risk. They mostly are
Mhm.
focused on vulnerabilities. So the model in these systems typically is your control system is made up of these assets. These assets have vulnerabilities. The more vulnerabilities in these assets as we add them up, and the higher the CVE score, CVSS score for these vulnerabilities, therefore is more risk. But all we're doing is adding up vulnerabilities. Vulnerabilities are not risk. It is a component of risk. It's, threats and vulnerabilities and consequences is the basic formula there. So we're looking at one of the three variables, adding that up and saying that that equals risk. It's a false premise, really. The
Mhm.
idea is on the right track, but the implementations thus far, um, commercial implementations that I've seen, are missing the mark, and and really giving people either a false sense of dread or a false sense of security, depending on how you look at it. If you have, everyone has Windows computers operating their operator stations, engineering workstations. There's always going to be a long list of vulnerabilities in Windows OS. So simply just saying if you add up all the vulnerabilities in your OS, that means your plant is at that level of risk. That's actually kind of overstating the risk, because it all depends on how the network is architected. Where are those machines? How many layers of protection do we have sitting on top of them? Firewalls and EDR and um, application safe listening. There's could be all kinds of technology that's actually protecting that machine, even though it is vulnerable.
Yeah.
Um, so it's either a false sense of security or false sense of dread, depending on how you look at it. The Where I'm going with this is what you really need to do is build a model, a risk model of your facility. Um, Ideally, it would be, very unique to your facility, but there's general ways you can build a model, starting with the network segmentation model of the facility. Build that risk model, and then you can inform it with real-time data. That real-time data might be, what are the current threats that we've detected? What are the known vulnerabilities in the system? Also, things like people, process, and technology. How well, like, have we patched these systems? There's a lot of data that you could then bring into that model to
Mhm.
then actually start to build a real-time model of your risk. That's the holy grail. It's easier to say than to do today, but technology is getting us there, and I do think we will see kind of real models for OT operational risk that can be enabled to be dynamic
Mhm.
and kind of self-updating.
What what kind of 'cause this industry loves standards. I mean, it's all they'd love to work with that. I mean, are there any kind of standards that help deal with this kind of stuff?
Sure. Particularly in OT, I'd say that the predominant one is part of the 62443 series. It's
Yeah.
called 62443-3-2. It's called Security Risk Assessment for Design. Um, Pretty familiar with that because I chaired the committee that
Mhm.
that wrote that for 7 years. Um, And it basically is walking through, and it's not rocket science. That standard leveraged many existing pardon me, existing IT risk management frameworks, such as those from NIST and several other sources that are cited in the bibliography. But we weren't trying to reinvent the wheel. What we're trying to do is say that there's some basic guidelines for how to assess
Hmm.
risk.
Yeah.
Uh, the things we did in that standard was to, for example, many of those IT risk management frameworks did not take safety into consideration. So that was a big differentiator for 3-2 is we had several requirements in there and built into the process to make sure that safety was considered as a factor, and other things like wireless technology and transitory connections. So things like USB connections and things like that were considered as well. So we tried to make it um, align it for the OT space and for control systems, but it's basically a risk management framework model based on a lot of previous good work, but applied to the OT space.
Hmm. Right. Then now there are plenty of assessment types of assessments out there, and where does consequence-based risk assessment fall into all the other types of assessments out there? And then on top of that, how often should a company do a consequence-based risk assessment?
Yeah, yeah, that's a great question. There are you ask 10 OT professionals about what a risk assessment is or what a cybersecurity assessment is, you'll get maybe 20 different responses because there uh, there it ranges everything from what I would call a basic gap assessment. There's vulnerability assessments. There are validated architecture design reviews, things like what TSA calls CATER assessments, and then there are actual true risk assessments. Um, so there's many different types, and that's important for users when they're specifying that they would like an assessment done of their cyber assessment done of their OT systems. What do they really want? There's actually you want a kind of a blend of multiple different types to really get a good picture of the risk profile of your facility. You kind of want to blend a few different types of assessments. So a gap assessment is really typically is going to be more of a questionnaire driven, measuring, evaluating the current posture of an organization and the technical controls around a system compared to some benchmark. Usually that benchmark is a standard. So say NIST cybersecurity framework is a good example, or 62443, or a company specific standard.
Hmm.
You go to that site, you meet with the people, you look through maybe some diagrams about the architecture and start asking questions. How do you patch? How often do you patch? Do you have network segmentation? How is it segmented? So it's usually question answer based on walking through the requirements in a standard and benchmarking that that particular site and that organization against the standard. And there's value in that. There's a lot of value in that. But it there's two things it doesn't tell you. It doesn't tell you risk. It only tells you that standard says you should be here, you're here. That doesn't mean that you necessarily have risk. It just means you're not compliant. Compliance doesn't necessarily equal risk. So the other part, people talking about vulnerability assessments and even like things like pen testing, where you're actually searching for, okay, what are the known vulnerabilities in the system? And not just the software vulnerabilities that you can put a CVSS score on, but vulnerabilities in terms of implementation. Was is the firewall configured correctly? We think we have network segmentation, but was it really implemented correctly? Sometimes on paper it looks good, lots of different subnets and VLANs, but if they're all routed to each other, you no longer have segmentation. You spend a lot of money but but you may not have achieved your goal of actual segmentation. So there's those vulnerabilities, and that's another type or another factor in the assessment is actually looking at real operational data for that system to validate those responses. It's not that people would necessarily are going to lie when you do the question answer, but they may not know. You ask a question is, have you segmented your networks? And say, yeah, yeah, of course we did. But then when you actually look a little bit deeper, you find that these implementation flaws, the way it was actually implemented, you're not as segmented as you think you were, for example.
Mm-hmm.
Or we did here, but we didn't here. Um, and then last but not least is the risk part of it. So now that you actually understand your gaps and your vulnerabilities, now you can sit down and talk about, okay, put that in context. What are the realistic threats that could attempt to exploit these vulnerabilities that we discovered, resulting in some consequence? And there, the standards all talk about breaking the system. You can't look at the system as a whole and try to answer those questions. You have to break it down into smaller, manageable chunks. So usually for a facility, we'll break it down into either unit operations or manufacturing lines. And then within those, um, security zones and conduits. And you kind of walk
Mm-hmm.
through the process, kind of zone by zone, answering those, having those discussions about threats and vulnerabilities and consequences.
Okay, but how often should an organization do this kind of thing? I mean, is it, I mean, it seems pretty involved. So, I mean, is it yearly? Is it, you know, quarterly? I mean, or
Yeah, yeah, I
yeah.
didn't. Yeah, sorry, I didn't answer that part of the question, but it varies. The first time you do one of these, we call it a 3D assessment, where you're looking at the gaps and the vulnerabilities and the risk, all that kind of holistic view. The first time you do one of these for a facility, it's going to be a heavier lift because if you had not done one before, you got to gather all that operational information, go through that. It might be drawings, it might be packet captures, it might be switch configurations and logs, things like that. You go through all that technical data to get a good understanding of the system. You do the gap assessment, the question answer part of it to get a good understanding of the maturity level of the organization.
Hmm.
And then lastly, you sit down and do a formal risk assessment, either in a cyber HAZOP or cyber bow tie methodology. So that's going to take some effort the first time. Once you've done it, though, to come back maybe annually or even every other year or even every 3 years to refresh it is not anywhere near as heavy a lift. If you've taken that process and particularly if you've implemented it in some kind of a good tool, a relational database type tool, so
Hmm.
you've got all that information. Now all you're doing every so often is refreshing the model. What changed with the system, what new threats may have emerged, what new known vulnerabilities do we have. Um, so for most of our clients, I'd say the average is probably a 2 year cycle, a 2 to 3 year cycle for a full refresh.
Hmm. All right.
Unless something, of course, the other driver would be a change. Like if you made a major change to the architecture of the control system, you're probably going to want to refresh then.
Hmm. Hmm. Okay. Now, in talking to you in the past, I kind of call you the father of cyber PHA. I mean, when we're talking about the consequence based risk assessment, is it possible to conduct a cyber process hazard analysis or cyber PHA or a cyber bow tie, and how do they benefit any kind of organization?
Yeah. So yeah, I've certainly been doing these for a long time. So my background is well, I started as a process control automation engineer. I started specializing in safety instrumented systems and functional safety about kind of midway through my career, and then I transitioned to cyber. So it was kind of natural for me to look at safety functional safety engineering and techniques and apply them to cyber. And I'm not alone. There dozens of people that have also kind of made that connection that, hey, we have really good, pretty mature processes for measuring process safety risk. And in OT, the we're also really ultimately we're interested in process safety or process integrity, may be a better term, because
Mhm.
um, if an OT system is compromised, it could result in a safety incident. It could initiate a safety incident, or it could prevent a safety incident from safety systems from properly responding. So there's a tight connection between process safety and industrial cybersecurity, as well as a cyber incident could also result in unwanted downtime and shutting down facilities and regulatory impacts. And there's a lot of connections between the two. Um, and really, a lot of people, myself included, think that the safety process safety engineering discipline and the industrial cybersecurity engineering discipline need to be connected and harmonized in many ways, or at least informing um, uh, the people designing safety should be informing cyber and vice versa. And a way to do that is through a cyber HAZOP or cyber PHA, or now we're also leveraging bow tie analysis, which again is another technique that came from safety engineering that um, myself and many others in the industry are now using that technique to do a cyber analysis.
Mhm.
What all of these methods have in common, whether you're talking about the HAZOP or the bow tie method, is it's a structured method, and it takes the system that you're looking at and it breaks it down into manageable components. When you're doing a safety analysis, we usually take the P and ID diagrams, and we identify nodes, and we discuss the hazards associated with that node. In a cyber HAZOP or cyber PHA, it's the same thing. We're taking the control system and we're breaking it down into manageable, what here we call zones and conduits.
Mhm.
The consequences of compromise, we can, if a HAZOP or a LOPA study has been conducted, a safety study has been conducted, that really can inform the cyber, because what you do, you go through those lists of, here are all the bad things that could happen to this system. Now, many of them could never be caused by cyber. A pipe corroding and having a loss of containment, that can't be caused by cyber. Um, but a valve failing to open when it's supposed to, a pump failing to shut off when it's supposed to, um, or vice versa, those could be caused by cyber, because ultimately those final elements are usually controlled by a control system.
Sure.
Um, and so if the control system is compromised, it could initiate that event that you've identified in your safety study. Um, Sometimes the valve is just stuck. If it's mechanically stuck, that's not cyber. But if the valve is stuck because it's being instructed, improperly instructed to be in the wrong position, that is a cyber
Sure.
incident. So what I like about cyber HAZOP, cyber PHA, cyber bow tie is you're taking that engineering discipline from safety and you're applying it to, and you're looking at it now from a cyber lens.
Mhm.
Could cyber cause these unsafe conditions, and what barriers, what controls do we have in place to prevent that? Are they enough? Do we have
Mhm.
enough barriers to prevent that? And if not, what could we do to improve those? So it's a
Mhm.
very structured analytical approach, and it ties the cyber to actual consequences.
Mhm. Okay, and, do you have any, I don't know, it's a lot it's always great to hear about any kind of case histories or any kind of, something that where, that is based on reality. I mean, do you have any, case history kind of things with cyber PHA or maybe a bow tie?
Yeah, probably hundreds. I don't know how many I can drop from my memory bank at the moment. I've done a lot of these studies over the last 15 years in a lot of industries and a lot of applications. There's one that's fresh in my mind though, and where this cyber it was a bow tie analysis that we did. Um, whether just a side note, whether you go with a has up or bow tie is almost a matter of preference for the for the for the for the company, for the user.
Yeah.
They ultimately they obtain the same result, which is helping you to quantify the risk associated with a uh, particular scenario. Rank the risk is probably a better term. They both achieve that same goal. HasOp is very structured. It's kind of a tabular approach, uh, um, whereas a bow tie is a more visual type approach.
Hmm.
So it's more graphical. There's a For companies that are already OSHA PSM regulated, they do HasOps all the time. People are familiar with HasOps. Transitioning to a cyber HasOp is pretty natural. Uh, so whereas other industries and sectors that are not under OSHA PSM and therefore may not be conducting regular HasOps or may not even know what a HasOp is, the bow tie is definitely seems to be a better fit. It's more
Yeah.
intuitive, it's more visual, it presents well to leadership. So it's a matter of preference. I just wanted to give that. So my case study, though, case study was is in the midstream pipeline sector. Um, and like most pipelines, there are terminals along the pipeline where material is stored. Whether it might be oil or refined products that are stored in tanks at terminals along the pipeline. And so, in this particular example, the we're going through the scenarios around the storage tanks and any
Hmm.
risks associated with that. And of course, all um, tanks always have level sensors to measure the level of the volume in the tank. And there's other variables. You know what product you're putting in, you know what product you're taking out. And we're going through the scenarios. And this was really what the risk assessment uncovered was um, where this particular client actually didn't somehow dropped the ball, accidentally did not put in the normal safety controls that they would normally put on tank level monitoring. So in this case, the tank level sensors went to a PLC. The the PLC also controlled the valves for inlet um, and outlet valves on the tank. So the scenario was basically tank overfill, very common scenario. What would happen if we're feeding product into this tank? We think the level is as this, but it's actually higher. Could
Hmm.
we overflow the tank and spill oil or gasoline on the ground and potentially ignite? Now, normally there's going to be additional safeguards that would protect against that, and that's part of this process. Is you go through and you ask those questions about, well, could this happen? Could is it possible that you could, you know, if you had a bad tank level, could you accidentally overfill the tank? Well, yeah, that's possible, but there's this safeguard or this safeguard or this safeguard in place that would prevent that. Sometimes it's a secondary level sensor going to a safety PLC. Sometimes it's more manual. That yeah, we have people that go out and they do rounds. They look at the sight glass. There could be a number of different safeguards preventing that. But in this particular example, as we're going through and asking those questions and going through the risk assessment, looking at the actual controls, the PLC itself, and where it was on the network, we discovered that there was unintentionally a bridge between the the engineering uh, the the PC to configure the PLC was sitting on both the PLC network and on the business network, which meant that it
Hmm.
had internet access. Again, something not intentional by the client, but something somebody did. So now this configuration engineering PC has network internet connectivity right to the PLC. So there's definitely a scenario where that the PLC could be compromised. And what we discovered is there was no backup. There was no secondary means of either detecting that or responding. It was an unmanned facility, so you couldn't even take credit for somebody uh, seeing the tank overflow and hitting an e-stop because it was unmanned. So that's kind of a lengthy explanation but that's the kind of thing that in going through these processes, it's those things that you find that would never come out in if you were just doing a gap assessment
Hmm.
and you weren't actually looking at drawings and network connections and talking about the actual consequences. What controls do we have to prevent the ultimate consequence, the spilling oil or gas on the ground?
Yeah. Uh, that just I mean, as you say, it's kind of like a small thing, but it sounds so compelling. I mean, how many organizations out there haven't done this kind of thing where that is just sitting out there waiting for it to
It's that stuff
happen?
that slips through the cracks, right? It was,
Yeah.
once people saw it, they're like, oh no, yeah, yeah, that's a big miss. We need to do something about that.
Yeah.
So,
And it's nothing intentional.
exactly,
It's just something
exactly.
that happens.
Things happen. Yeah, these facilities, they've been around for a long time. A lot of different, and in fact, many times they've changed owners. Many times, a lot of different contractors coming in and coming out, and so if you don't periodically take a kind of a real hard look at, particularly at those things where there are major consequences, so
Yeah.
you should like this, storage tanks. You should always be doing an assessment of your tank farms.
No, in that kind of assessment, was that the first time you had gone through it and did that bow tie, or was that something that had been, you did after, like, on a refresh or something?
That happened to be an initial assessment. We had
Hmm.
done other assessments with that same client at different facilities.
Yeah. Alright, no, I find that interesting. I mean, that's kind of as you were saying before, like, when the first time you do it, it can be a little bit more lengthy, but you find out a lot of and that ends up being the baseline, I guess, more than anything else.
Hmm.
Now, I hate to bring up, AI in this kind of thing, but, because that seems to be what everybody always wants to talk
Hmm.
about, but how would AI play in this kind of environment?
Hmm.
Or not at all?
I, I I think there's always opportunities to use AI, even even if it was just as simple as using AI to help come up with realistic scenarios to look at. So
Hmm.
you could ask AI, um, we'll go back to my tank farm example. Uh, what are some of the hazards associated with a tank farm? What are the typical safeguards and controls that should be in place? What do the standards say? Because there's API standards that are actually um, um, quite well developed and actually prescribe the types of tank level monitoring type controls and you know
Hmm.
so you could definitely use AI for research to help make sure that you're looking at everything um, that you're building a good model.
Yeah. Yeah.
Another thing you could use AI for more after the fact is after you've done your risk assessment and particularly for a company that has multiple facilities, say they operate, refineries and pipelines and tank farms and um, shipping, ports and terminals and jetties, um, that you could start to look at put some of that into a more a private AI
Yeah.
model, but to start to mine that data to start to look for, tell me effectively tell me what I'm missing, like look through all this data, help me extrapolate that to my other facilities, help me look
Mhm.
for trends.
Yeah.
There's probably unlimited use cases for how you could use AI. Once you have data, that's the beauty of AI, is it can help you analyze that data.
Yeah.
Yeah. All right. Now, I like to always, whenever I do these things, to kind of give a list of best practices. And we don't have to have an extensive list, but could you give like, I don't know, 3 or 4 or 5, whatever you want, best practices in setting up some kind of consequence-based risk assessment?
Yep. I would say probably the first and foremost is select a methodology. Um, I guess select a standard. Um, there's not a lot of choices there. Really, the 6443-3-2 is the predominant
Mhm.
standard. But there are others that you might want to reference. So, but more importantly, is a methodology. The standard does not prescribe a methodology, and that was intentional. ISA standards in general are meant to be performance based, not prescriptive. And so the standard just kind of says these are the requirements to conduct a good risk assessment. How you do that is largely up to you as an organization. Whether you want to use a cyber HAZOP or a bow tie, you could do fault tree analysis. There's failure modes, effects analysis. There's bow ties. There's a lot of different methodologies out there to meet the requirements of the standard. So pick a methodology. Um, and then the next thing is pilot. Um, Pick one facility, and not even the whole facility. Maybe pick one facility and a portion of that facility and pilot process.
Mhm.
Maybe if you have a lot of like certain types of facilities, maybe do one of each type of facility. Pilot it, get a core team together that and cross-disciplinary team. So engineering, operations, IT security. Um, get a good facilitator, somebody familiar with the process to really kind of um, to guide the process. Because one people it can go off the rails if it's not well controlled. You want to have discipline as you go through the process, um, and then stay true to the process. Um, to really you may not see the benefit on the first pilot. You may have to do 2, 3 to start to get it kind of a rhythm going with the team, to get people on the same page, to start to really see the benefits. So kind of, I guess what I'm saying is kind of stick with it. Um, give it a shot. Get um, a good facilitator makes a huge difference. And then be consistent. That's probably the last and most important thing is once you've picked a methodology, you want to be consistent. You want to calibrate to your threat environment, your consequences. Start to build out libraries. If you have a lot of facilities, you can say, well, these are the typical threats and consequences for this type of facility. So these are the ones we're gonna focus on. You can add additional ones, but this is the going in list
Mhm.
kind of thing. So it's all really about a program. Ultimately, it's building out a risk management program and being consistent in how you do it. Because at the end of the day, risk is relative. What you're looking for is, you've got a number of risks in your facility, though you want to focus on the highest risks and address those first.
Okay. All right. Well, John, I appreciate you taking the time to spend with us today, and that because that's about all the time we have for right now. So I will say, along with John Cusimano, and I want to say thanks for listening, and we'll catch you next time on Today with ISS Source.
All right. Thank you, Greg.